expressions to earlier because I think they're easier to work with rather than the radical boxes when you're simplifying stuff. So this is review grades. Okay? So fractional exponents. Says for any real number b and any positive, that should be positive b, and any positive integer n, we can write it as a fractional exponent. We've done this before. We just take whatever the exponent is, in this case b to the 1, and then put that on the top of the fraction. And whatever is in the index is whatever outside the box, put those on the bottom of the fraction. Right? So we're going to do this. Okay? This is true except when b is less than 0 and n is even. When that happens, a complex root may exist, meaning we're going to get an imaginary number. Okay? Imaginary numbers only happen when we have an even root. So we have a square root, fourth root, sixth root, whatever. And if b is less than 0, meaning we have a negative. Okay? For example, how can I take this one, 27 to the 1/3, and write it as a box?
Third root of 27.
Third root of 27. Yeah. Okay? How can I write this one so that it has a box? What happens?
Imaginary.
Yep, so you have to pull out that I, and what's the square root of 16? 4i. What happens over here with the square root of 27? 3. So all this, example 1, you've done it before. It just is asking us to write it in the other form. It says write a radical form. Yeah, I'm going to show you. Hold your horses. Okay, write a radical form. Radical form means put a box in there. When it says exponential form, it means put the exponent so it's a fraction. So in radical form, how do I write it with a box?
Oh, 6 to the square root of x.
X to the 1, right? The third root of x. Or sixth root of x. Okay, how about b? How can I write that so we have a fraction? Okay, do we need to do any more examples? You guys know how to do this already, right?
The next one is 5, 8, and the first, right?
Right, the fifth root. Yeah, fifth
No,
root.
what about F? Is this C needed?
Okay, well tell me about f.
Oh, this is there.
C needed.
Yep. What happens when I have negative exponents? Because it's not technically simplified, but it's a negative. We don't need it. What happens with negative exponents? And we did this last chapter. Remember? Remember when it is the top of the fraction? Switch it, we move it to the bottom. It's the bottom, we move it to the top. In this case, is it the top or the bottom? It's the top because it's over 1, right? So we put it in the bottom and make it a positive. Do E. Okay? Do E. Alright, tell me about it.
Fourth root of d to the 7.
Fourth root of d to the 7. Yep.
Yeah. That's easy.
Good. Okay.
That's a little like that.
Evaluating the expressions. Evaluating expressions. First of all, we've got a negative exponent. What are we going to do first? What should we do first?
The fraction.
Right, put in the fraction. So move it to the bottom, in this case make it positive. So we have 1 over 81 to the 1/4. Okay, is 81 a perfect fourth?
Um,
No, it's not.
1 over
3.
3.
I was going to say, I think so. I think it is.
Oh, so the answer is 1/3.
Yep. Because it says evaluate beginning with 1 and 65. One number. All right, how about B? What are we going to do there?
Yeah, it's the radical form of the third root of 260 squared.
So we could square it first. Sure. Okay, so I have no idea what 16 squared is.
46656.
I'm sorry, say again.
46656.
6646
56.
5.
It's 36.
Crazy.
And everybody knows how to type the third roots in your calculators, right?
Yes.
Do we need to do more examples?
No.
Okay, let's go down here. This one, same kind of idea as what we just did. This is just saying that I can write it when I have something that's inside a box that's squared to the third or something. I can move that squared or third or whatever to the outside and I'm going to get the same answer. In other words, if I was going to write this one, so I had a box, so I put it in radical form. How could I write this in radical form?
Third right of 27 squared.
Okay, I can write it like this. What's 27 squared?
729.
719. Alright, and then is this the perfect third?
Probably.
Yes.
9. Okay, so I could do it this way. That's one way to work the problem. You could also, I could also write it like this. So I have the third root of 27, but the whole thing is squared. Okay, because this one's nice and easy, this one's easier, because we already know the third root of 27 is 3. So we would have 3 squared, which is 9. It's so much easier to do it that way.
Because the 3 does the,
Why don't you just jump out of the first place?
You know, I'm saying you can do it either way.
The lady.
Wrong.
Hey, I'm just going to do it the first thing it's easier.
Whichever way makes better sense to you, come up with the same answer. All right, tell me about this one. How can I write it? How can I write it so we have a box?
you can do 4i cubed.
4i cubed? How did you figure that out?
Because you cube the whole square.
Right, so we could write it as a square root of negative 16, the whole thing, to the third. You're right. And this turns into 4i. So remember when we have something with a power on the outside of the parentheses, we kind of have to distribute that power, right? Not
64. I think it's 64.
64. Why is it a negative 64?
Because I, when you times 3 times, it becomes a negative I.
Right. I know it's been a while since we worked with I. Let's review. Okay. So I is just I. What's I squared?
Negative 1.
Negative 1. I to the third gets us,
Negative I.
and I to the fourth.
What's that?
All right. Any questions on the front?
Why is I squared cubed still? Where did that go?
Because we said I cubed is really negative I.
Oh, that's
So we just said negative times I.
okay.
Anything else? All right, let's go on to page 2. In the formulas, big C equals little c times expected quantity 1 plus r in can be used to estimate the future cost of an item due to inflation. Big C represents the future cost, little c represents the current cost, r is the rate of inflation, and n is the number of years for the projection. Okay? So then it says we can use this to estimate the cost of video games within 6 months. Suppose a system costs $390 now. How much would the price increase in 6 months with an annual inflation rate of 500%? All right, so let's see what we can plug in. Okay? What are we looking for? Which variable are we looking for? All right, well, what's this? Let's see. They give us information. They say 6 months. They say system costs $390 now. How much the price increase in 6 months? Annual inflation rate 5.3%. Okay, so 5.3% is which variable?
The R.
It's the R. Okay, this 30 or 390 is
C.
big C or little c?
Little C.
Little c, because it's cost now. We want to find the big C. We're looking for this guy. What's the 6 months? Right, it's half a year because it's half the in, because it says in is the number of years, 6 months is half a year. So they've already put a half on it for us. Okay, so big C equals little c times 1 plus r, which I'm going to change so it's a 0.0 to that half. Okay, order of operations, what are we going to do first? Parentheses, so we're going to put these together. And what?
Then you have to take a picture of it.
So use your mini name calculators, figure out what the square root of 1.053 is.
It's a rush.
Yeah, I'm sure it goes on forever and whatever. So leave all those decimal places on your calculator and take it times 398 and we come up with our answer.
Yeah, 1 cents.
20 cents? Yes, I agree. Does it include taxes?
Does it also include anything in each one of this? You'll put it down.
True. What's something new about?
All the stuff you have to buy for it nowadays.
Yeah.
Like the Nintendo, you can put on Wii. One game, yeah.
Okay, let's read this question carefully because it says how much will the price increase in 6 months? Is this how much it's going to increase by? No, this is how much the cost is now. How are we going to figure out how much it increased by? Subtract it, yeah. So we're going to take where it is now minus where it started.
Oh, wait, I see from that. Wait, so that's not the answer.
Oh, well, it's going to increase, so it's going to want it to be a positive, but yes.
No, what you're saying, it'll be where it is 6 months from now, not now. Minus where it is now.
Good job.
Yes. Yes. $10.20. Yep, that's how much it's going to increase by. All right, you guys understand how to use this equation? This formula? Okay, do you want to go on?
No.
I mean, do you want to?
No.
You don't want to do this
No, I
one,
don't
right?
want to go on.
Okay. We're going to go.
Or do that.
We're going to go. So simplifying expression with fractional exponents. So all the properties of the powers we learned back in section 6.1 also apply to rational exponents. That means if we're multiplying the base of the same, we add exponents. If we're dividing the base of the same, we subtract exponents. If we have a power to a power, what do we do with the exponents? Multiply. So all those properties still apply when we're working with fractional exponents. In order to be in simplest form, the expression must have all positive exponents. All positive exponents, no negatives. If it's negative, remember you move it from the top to the bottom. Any exponents in the denominator must be a positive integer, not a fraction. Because over fraction, it's a root. You cannot have roots in the bottom of a fraction. When simplifying expressions containing rational exponents, leave the exponent in the rational form rather than writing it as a radical. In other words, if they start a problem where it's a fractional exponent, leave your answer as a fractional exponent. If we look at these over here, notice they have square root boxes or fourth root boxes. That means your answer needs to have a box at the end to leave with a fraction. Does this make sense? Okay. Alrighty, evaluating. Tell me on this one, the bases are the same. What are we going to do with those exponents?
Well, add them together.
Add them together. They make it nice for us. We don't have to change the denominator here. So we're just going to end up with 6.
Really hated doing that.
Maybe it's going to put another in the box.
Since it's starting with fractionals, we'll end with fractional exponents. That's it. That's all we have to do. Okay? How about B? What are we going to do there? Put in the bottom because it's a negative exponent. Okay, but we cannot leave it at the bottom of the fraction because remember this is really a box, a radical box. I can't stay down here. What's that next? Multiply by itself. Ooh, close. What is it?
It's reciprocal.
It's reciprocal.
No, you had 1/6.
It is where
Add 1/6.
B 1/6.
Oh,
Yeah, I go with multiplying by 1/6. Why? Why are we multiplying by?
Yeah.
So you taught us how to do that.
Okay, well why? Why do we do it that way?
It's easy.
so you can get like just beyond the bottom.
Just b on the bottom because this turns into add exponents. We end up with b6 over 6, which is really 1, and it's just going to be b on the bottom, right? What happens on the top? You just do it. Yep. And there's nothing. There's just the 1 times it, so you just do it.
You can have fractions and the exponents in your inner fraction.
Yes, you can't just leave. You cannot leave them at the bottom, but you can have them on the top.
Okay.
That's okay. All right. Do I need to do more examples like these, or you guys got it?
No.
Got it? Yes? Okay, let's go on here. It says when simplifying the radical expression, always use the least index possible. Index is the number that tells us what the root is, in this case like fourth root. So using rational exponents makes the process easier, but remember to write the answer in radical form. In other words, if they start with boxes, your answer needs to have a box at the end. Don't leave it with fractions. But it was a whole lot easier to work these problems if you put them as fractions first and then transfer them at the end. Okay? So I will first take this and write it so we have fractional exponents. How would I write this with the fractional exponents? Okay. Over. Yep, 3 to the half. Okay, so remember with our exponent rules? Since we're dividing, we're going to subtract the exponents. However, we can only do that when our bases are the same. Okay? Bases are not the same, so we have a 27 and a 3. So how can we get the bases to be the same?
2 over.
Say that again. Let's think. Can I take 27 and write it somehow with another exponent so that I have a base of 3? 3 to the something gets 27?
2 over 4.
3 to the what? 4th? Oh, okay. 3 to the 3rd is going to get us 27, right? And it's still the 4th over 3 to the half. So we've got a power to a power. What are we going to do with those exponents? Okay, what did I lose? I heard a lot of good.
3 to the 3rd.
Right, because 3 times 3 times 3 gets us back to 27. I just rewrote 27. Okay, so then I have a power to a power. What do you do to this 3 and a 4? That's try to multiply by multiply, so 3 fourths. So we have 3 to the 3/4 over 3 to the half. Now our bases are the same, they're both 3's. Now we can do what with our exponents? Subtract them. So this is 3 to the 3 over 4 minus half, which would be
Could we do it the long way?
oh wait, we can't leave it that way. Can we do it the long way?
What's that? Like times the top.
It's bottom.
You could, I think it's a little easier just to do that.
We'll be wrong. You'll move this way.
Why would you want to multiply by
Okay, I have a question.
half? What? Because then you're just going to have to
When you times it by
simplify that.
3 and a half, how would you, like, 3 3/4 is 3 and a half.
Well,
Okay.
okay.
Could you go through it and times it by 3 and a half? Bottom.
Could, but you're just
I don't know, just go through it because I'm not sure how to do it. Okay. I'm saying bottom part or about the top?
Well, then we're going to add exponents,
You
right?
can't add those.
You can because the bases are the same. So 3 is closest, then you can't do it.
Oh, okay.
But this way, we made the bases to be the same so that it'd be easier so we can just subtract rather than having to do it this way. Does that make sense?
But we can do it that way.
Yes, you can do it that way, but you're making it so much harder and much more work than you have to.
No.
Yeah, you really are. All right, let's look at B. Let's look at B. I would first put it so that we have all fractional exponents. So tell me what was correct. What will we have?
64 1/3, C 6 over 3.
Right, because 6 over 3 was really
4
2.
Z squared. That's what you get.
4 because 64 is a perfect third. You're right. It's 4. So 4 Z squared.
That was just kind of an extra step.
Okay, C. Looks a little bit trickier.
That means we have to expand solution.
Can you spell all of
No solution.
3x minus 2.
3x minus 2.
Minus 2.
Yeah.
Okay, got it.
I don't like doing it.
Because, why do you have to do that? Right, because we're going to take it times the conjugate so that we don't have any radicals in the bottom. So it's the same idea as what we were doing before with the box. So in this case, we just have fractional exponents instead. Okay, so we have to FOIL top and bottom because we have adding and subtracting here. So I would think, okay, 3 to and x to the half times x to the half means I'm just adding the exponent, so I just have 3x to the 1, right? Okay, and then I always go to inside first. I think you're supposed to go outside first instead of, yeah, this FOIL. But when I'm a terrible speller and I never remembered how to spell FOIL because I can never remember if the I comes first or the O comes first. So outside and inside doesn't matter what order you go anyway because I never remember. I know.
I never actually wrong matter what order you're going.
I know, which is good because otherwise I think
Spelled boy.
I am terrible at spelling. And in middle school it was even worse. I've gotten better, believe it or not, than what I was at first.
Play Scrabble
When
and
it's,
then our teachers.
Scrabble was the worst thing ever.
How do you hate it so bad? It's all math.
Scrabble?
Yeah.
No,
It's spelling.
After you learn how to spell decently, it's all math.
Well, I don't know how to spell decent, that's my problem.
Can you spell decently?
Probably not. Decently.
Yeah.
Is that right?
Hey!
That's
And you speak the singular.
Brittany typed into the word.
All right, let's finish up this problem. Let's finish up this problem.
Okay, so it's just
500 pages to like practice. Sometimes you can't understand the spell.
All right, can we simplify and color again?
What's x? This is 3x.
Oh, excuse me. Let's try it. Thank you for fixing that. Okay, so what else did we do yet? Nothing. Yes. Error. These guys are the same, right? Can we add them together?
No.
Yes.
10, 14.
14.
If only I could watch the videos at home that online to watch this one just here works than me.
I keep circling the wrong.
Want to go backwards?
All right, anything else? You guys want to go through all this page or do you feel pretty good about it?
You feel fantastic.
Feel pretty good about stuff? It's in the book, yeah. Yeah. I didn't write it down. Oh, let's see here.